Okay, dokes, let us try to solve this question. Now let's read the question together. The question it reads as follows. Question number 10. An experiment is conducted to investigate the relationship between the frequency of light incident on a metal cathode and the maximum kinetic energy of the emitted electrons from the surface of a metal cathode of a photocell. Now the graph represents the results obtained. The graph of maximum kinetic energy versus frequency of light. And this graph, it definitely has the y as well as the x-axis, whereby our y-axis in this case represents the maximum kinetic energy. And then the x-axis represents our frequency in hertz units. Now, before we go through the questions, I want us to talk about a few basics that we have learned in this concept, which is called the photoelectric effect. Now, in photoelectric effect, we talked about what? Before I talk about the photocell, in photoelectric effect, we talked about what? For an example, let's talk about a metal. There are different types of metal. We have the sodium metal, the lithium metal, the gold, whatever metal that you can think of. We know that in physics we have learned that the metals are good conductor of electricity because they have electrons. Now these electrons, we call them the delocalized electrons. Now if we have a metal surface, if we have a metal just like this, for an example, let's say we have a sheet of metal. Now in this sheet of metal there are definitely free moving delocalized electrons in it. There are free moving delocalized electrons in this metal. Now if light is shown towards the metal, what is going to happen? If light is shown towards metal, what is going to happen? Remember, lights have particles, and these particles are collectively in energy form. We call them the quanta. Okay, and for singular is quantum, meaning the particles of light, we call them the photons. Now these photons are clustered together in a form of energy. They are called the quanta, meaning the quantum. Okay, other than that, so if light is shown towards the metal surface, this light with their photons, these photons, they are going to eject the electrons out of a metal surface due to the energy conversion. Now here we will be having a light energy. A light energy will be converted into a kinetic energy, the work function as well as the heat energy. So now when this light is shown towards this metal surface, what is going to happen? It depends on the frequency of this light. Now the frequency of light, it is not the same. Now if the frequency of light is less, we have what you call the cutoff frequency of the metal. We have what you call the work function of the metal. We have what you call the cutoff frequency of the metal. We have what you call the work function. We have what you call the work function of the metal. Now, if the frequency of the light, it is less than the cutoff frequency of the metal, the electrons won't be ejected out of the metal surface. If the frequency of the light is equals to the cutoff frequency of the metal, the electron, it is going to be ejected out of the metal surface, but it is only going to sit here. But when the frequency of the light, it is greater than the cutoff frequency of the metal, therefore that's whereby your electron, it is going to experience increase in kinetic energy. Meaning when frequency, it is less than cutoff frequency of the metal, that means the kinetic energy of these electrons, it is also going to be less than 0, meaning it's going to be negative. But when the frequency is equals to the frequency of the light is equals to the cutoff frequency of the metal, then the kinetic energy now, it is equals to 0. And when the frequency of the light, it is greater than the cutoff frequency of the metal, therefore the kinetic energy will be greater than 0, meaning this photo electron, it is going to experience the kinetic energy. Remember, what is kinetic energy? It's an energy that an object possesses due to its motion. Okay, all right. Now here, remember, we are going to experiment, or we are the experiment, it has already been done, whereby they were experimenting the frequency of the light and the what, the frequency of the light and the maximum kinetic energy of the electrons emitted out of the metal surface. But again, because in this experiment they are talking about a photocell. What is photocell? A photocell, it has two electrodes. A photocell, it has electrode which we call the cathode, and it has electrode which we call the anode. Now, the cathode of your photocell, it is connected to a negative terminal of your battery, while the anode of a photocell, it is connected to a positive terminal of a battery. Now, because cathode, which is this electrode, it is connected to a negative terminal of a battery, that means cathode, it will be negatively charged since it is connected to a negative terminal of a battery. Meanwhile, the anode, which is connected to a positive terminal of a battery, it is going to be definitely positive. Okay, now remember, because this is a photocell, these two electrodes are closed in a glass container. Now this glass container, it has vacuum. It doesn't have matter, meaning there are no particles that are moving around in here except the particles that are involved in this system, meaning it is vacuum space. Now vacuum space, there's no matter, there's no interaction of other particles except the particles that are involved in this case. Now in photocell, this is what is happening when light is shown towards the cathode. Remember, cathode, it is negatively charged. Therefore, the electrons will be ejected out of this metal surface, which is called the cathode. As the electrons are being ejected out of this metal surface, the electrons, because are negatively charged, remember, anode, it is positively charged, and therefore there will be a force of attraction. There will be the electrostatic force between the electron and the anode, and therefore the circuit will be complete. Now circuit will be closed and there will be flow of current in this circuit. Okay, now that's what you call the photocell. This is an experiment of photocell. But because here they're investigating the relationship between the frequency of the light and the maximum kinetic energy of the electrons that will be ejected out of this metal cathode, which is negatively charged, we want to understand that as the frequency increases of this light, what is going to happen to the kinetic maximum energy of these electrons. Now, according to our graph, because this experiment, it has already been done, according to our graph, look, remember, on the y-axis we have what we call the dependent variables, and on the x-axis we have the independent variable. So that means the maximum kinetic energy of the electrons depends on the frequency that is being used to be shown on the metal surface, in this case, which is the cathode. So the frequency of incident radiation of your incident ray, the kinetic energy of your electrons, it will depend on the frequency of the incident ray that it has been used to eject them electrons out of this negative electrode, in this case, which is called the cathode. Now, okay, let us talk about this graph. Now this is our maximum kinetic energy. In this case, our maximum kinetic energy is negative. And what is the frequency? The frequency is 0, meaning there are no light shown towards this electrode. But as the frequency increases, what is happening with our kinetic energy? Our kinetic energy does also increase, meaning the relationship between the frequency of the light shown towards the cathode, it is directly proportional to the maximum kinetic energy of the photoelectrons that are being ejected out of a cathode, which is, in this case, is a metal. Okay, they are inversely proportional. All right, now other than that, let us try to solve these questions. Now 10.1, it says, for this investigation, write down the controlled variable. What is controlled variable? It's a variable that we control, that it doesn't change. Meaning, in this case, what do we control? We control the cathode, the metal surface. The metal surface, it is the same throughout. You understand that we control the metal surface, okay? And therefore, what is the dependent variable? The dependent variable is going to be your y-axis. In this case, it is a maximum kinetic energy of the electrons, okay? The maximum kinetic energy of the electrons emitted from the metal surface, in this case, which is the cathode. Name the phenomenon on which this experiment is based. The phenomenon on which this experiment is based is called the photoelectric effect. That's the phenomenon this experiment is based on, to photoelectric effect, which is what I have just explained to you. Now define the term work function. Now let's talk about the work function. What is work function? Remember, I said this symbol, it represents what we call the work function. This is what we call the work function. And this is what we call the cutoff frequency. You can call it the cutoff frequency, or you can call it a threshold frequency. I love frequency. I love calling it the cutoff frequency instead of the threshold frequency, but you can also call it either way. You can call it either threshold or cutoff frequency, okay? Now, what is work function? Work function is a minimum energy that is required to eject the electrons out of a metal surface. Remember that your light or your incident ray, it has its own frequency, it has its own wavelength, it has its own energy. Now, if energy of this light, same applies with the frequencies. If energy of this light is less than the energy of this metal surface, in this case, which is the work function, if it is less than this, therefore there will be no electrons ejected out of this metal surface. But when the energy of this light is equals to the energy of this metal, which is work function, there will be electron that is going to be ejected, but it's not going to move, meaning it's not going to possess kinetic energy, okay? But when the energy of the light is greater than the energy of the metal, in this case, which is work function, therefore there will be ejection of electrons, and the ejection of electrons are going to experience what? The maximum kinetic energy, meaning they're going to move away from this metal plate. Same applies to here on photocell. This condition does also apply on photocell. Now calculate the value of x as shown on the graph for only 3 marks. Now this is our graph. Where is value of x? This is the value of x. The value of x represents the work function. So what is work function? The energy from 0 to x. This is what we call the work function, okay? That minimum energy that is needed to eject the electrons out of a metal surface. Now, how are we going to determine the value of x? To determine the value of x, remember we use this formula. So 10.4.1. Remember, when we calculate energy, we're going to use this formula. E is equals to h multiplied by f. But in this case, we are not talking about the energy of a photon. We are talking about the energy of a metal surface, in this case, which is work function. We're still going to use the same formula, but the symbols are going to be a little bit different. Now, to determine the work function, we're going to say Planck's constant multiplied by cutoff frequency all the time, okay? Because the work function and the cutoff frequency corresponds to one another. So in order for us to get the work function, we're going to use this formula. Now, what is Planck's constant? Planck's constant is 6,63 times 10 to power negative 34 multiplied by the cutoff frequency of this cathode. Now, from here to here, we are talking about the cutoff frequency, okay? So this is a cutoff frequency from here to here to here to here to here to here up to here. Frequency of this interval, it is not enough to eject electron out of a metal surface, but frequency at this point, it is equals to frequency of the light shown on the metal surface, meaning this is the cutoff frequency, okay? So now the electrons are going to be ejected out of the metal surface, but they are not going to possess the maximum kinetic energy. So in this case, the cutoff frequency, it's we have 0,5, 1, 2, meaning the difference is between here and here, it's we're gonna say 0,5 divided by 2, which is 0,5 divided by 2. Sorry, not 0,5 divided by 2, it's 0,25, meaning Each and every line represents 0.25. This is 0.25, 0.25, 0.25. But now, how many lines are there on cutoff frequency? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're gonna say 7 multiplied by 0.25, meaning here we have 1.75. Okay, and here we have 1.75. Let me see, we're gonna say 0.25 multiplied by 8. I want to check something. It's 2.7. Yeah, all right, meaning the cutoff frequency in this case is equals to 1.75 times 10 to the power 15 hertz, meaning we're gonna have 1.75 times 10 to the power 15 hertz. And then when we punch this on our calculator, we're gonna say 6.63 times 10 to the power negative 34 multiplied by 1.75 times 10 to the power positive 15. And how much do we get? We get work function is equals to 1.162 decimal places times 10 to the power negative 18 joules. And it's very important for you to write the units for your parameter. In this case, work function is going to be in joules. Okay, now that's the work function. Okay, and then 10.4.2, it says to us, calculate the frequency of the incident light that will emit electrons from the surface with a maximum speed of 5 times 10 to the power 5,23 times 10 to the power 5 meters per second. Now here we are given the speed of electron that it has been ejected out of the cathode. Now immediately when electron moves with a certain velocity, it possesses a kinetic energy. Now in order for us to calculate the frequency of the incident light, remember we're gonna use what formula? E is equals to work function plus change in EK maximum. Okay, so remember we are asked to determine what the frequency of the light. Remember, this is the energy of the light. So to calculate the energy of the light, like I said, we use this formula H multiplied by F. So we want that F which comes from the energy of the light. So E is equals to H multiplied by F, Planck's constant multiplied by the frequency of the light, and the energy of the light is equals to work function. It has already been determined on top, which is 1.16 plus, now here it's 1/2 mv squared. This is a formula for kinetic energy. So what is H? It is a Planck's constant, which is 6.63 times 10 to the power negative 34 times F, which is what we are looking for, is equals to 1.16 times 10 to the power negative 18 plus 1/2. And then what is the mass? Mass is the mass of the electron. Now if you forget the mass of electron, guys, it's given here in the formula sheet. Oh, it's removed. They always give you the magnitude of mass of an electron, even the Planck's constant. If you forgot the mass of, just go back to your question paper and look for mass of electron. Now this, it is the mass of the electron. Where is it? Mass of electron. Okay, mass of electron is 9.11 times 10 to the exponent negative 31 times the velocity. Remember the velocity, it was also given. What is the magnitude of the velocity of the particle? It's I don't have space here, I'm gonna just squeeze it right here. Okay, it's 5.23 multiplied by 10 to the power of 5, and then we close this in a bracket. Now as you continue to calculate this, we have 6.63 times 10 to the power negative 34 multiplied by F is equals to, let's punch this on our calculator, 1.16 times 10 to the power negative 18 plus 1/2 times 9.11 times 10 to the power negative 31 multiplied by 5.23 times 10 to the power positive 5. Yes, it's positive 5. And then for this side we have 1.16000 times 10 to the power negative 18. and therefore I'm going to divide both sides by h to determine the value of f. Now in order for me to determine the value of f, I'm going to say f is equals to, I'm going to say answer divide by Planck's constant, which is 6,63 times 10 to power negative 34, and my answer would be, frequency would be of the light 1,75 times 10 to power positive 15 hertz. Okay, now this will be the frequency of the incident light. Now the last question, it says to us 10.5, the intensity of the light is now increased. State how this change affect the current in the photocell. Now look, the intensity of the light, it does also refers to the brightness. If the brightness of the light is increased, what is going to happen to the number of electrons that are ejected out of the metal surface? The number of electrons are going to increase also. Now for an example, let's say we have a metal surface. Now let's say we have only one incident light ray, meaning this one incident light ray, it is going to eject only one electron. But if we have more than one, maybe we have two incident light rays from the radiation, meaning we're gonna have two electrons out of this. Meaning the more we increase the intensity, we increase the particles of what? We increase the particles of the photons of the light. Meaning we're gonna release a lot of electrons if we increase the intensity. Now here they say, when the intensity of the light is now increased, state how this change will affect the current in a photocell. Meaning the current in a photocell, it is going to increase. Why the current in a photocell increases? We're going to explain that. It increases because increase in current, it's due to high number of electrons. So when you increase the intensity, you increase number of electrons. So increase in number of electrons leads to increase in current. Okay, all right.